Hi everyone. In the previous video we learned about trigonometric ratios and how if you have three sides you can make six possible ratios, of which three are reciprocals of the other three. So here I'm going to show you some examples for problems which ask you to state the six different ratios. So remember the acronym SOHCAHTOA. So we will use that for this triangle. The reference angle is theta. The sides have been named y, r, and x. So we can start by writing the names of these sides. That's the hypotenuse. If this is the angle, y is going to be the opposite, and this is adjacent. With that identified, I can now write sine theta as opposite over hypotenuse, which becomes y over r. Now the function is called sine, but when we write, we just use the first three letters, S-I-N. Similarly for cosine, we just say cos, cos, adjacent over hypotenuse, which from the figure is x over r. And tangent, which we write as tan theta, is opposite over adjacent, which is y over x. Then the reciprocals for sine is cosecant, which we write as CSC theta. Because it's the reciprocal, it's just going to be h over o, which is r over y. For cosine, the reciprocal is secant, and we use SEC, sec, and that's going to be h over a, which is r over x. And for cotangent, we use cot, COT, which is a over o, which gives me x over y. Similar procedure for b. Again here, that's the hypotenuse, opposite to the angle, and adjacent right here. So this time I'm going to go quickly. Sine theta is opposite, which is y over hypotenuse t. And I can immediately write cosecant theta is just the reciprocal, so t over y. Cosine theta is adjacent, which is w over hypotenuse, which is t, and the reciprocal secant t over w. Tan theta, opposite over adjacent, so y over w, and the reciprocal cotangent w over y. Now the last example is a different type where I'm going to be using numbers, and you will notice the hypotenuse is missing. But we've learned something before about right triangle which we can use to find the hypotenuse. Let's say I call this h, then I can use the Pythagoras Theorem, which tells me that h squared is 3 squared plus 4 squared. I can plug that into the calculator as 3 squared plus 4 squared gives me 25. So I know h is going to be square root of 25. Again, using the square root button, and you can use this button called answer, which takes the previous value, and I get 5. So now I have my hypotenuse as 5 inches. This is my opposite, and this is adjacent. So the procedure is the same. I go sine theta, opposite over hypotenuse. Therefore, cosecant is the reciprocal of that. Cosine is adjacent over hypotenuse, and secant is the reciprocal of that. Tangent is opposite over adjacent, and cotangent is the reciprocal of that. Alright, so those were some examples of finding the trig ratios. Now, the next thing is, so far we have been looking at ratios of triangle, but we can create a different object out of this idea called a function. And these functions are called trigonometric functions. So a brief introduction into what a function is. The easiest way to think about a function is that it's a black box where you get an output when you put in an input. Now a calculator is sort of like a function. Each button does something unique. Typing 56 gives me 56 on the screen. Plus 65 and then pressing enter gives me an output of 121. So that's the basic idea for a function. For example, if you have a simple function which adds 5, if the input is 1, what is the output? Well, you add 5 to 1 and you get 6. If the input is 3, you get 8. If the input is 5, you get 10. So on. Which means that if I take any angle, then these trigonometric functions can take as input, they take angles. Input is going to be an angle and the output is going to be a ratio. So let's see how to do that. Sine 60 degrees. You go to your calculator. First of all, you need to make sure that you are in the right mode, which is degrees. So you can go on to mode, and if you look at your calculator, it may have 2 or 3 options: degree, radian, gradient. And you can use the arrow to toggle. The one that is selected will be in dark, so make sure it's in degrees and you press enter. And then you go back and you go sine of 60 and it's going to give you root 3 over 2. And that's the ratio. Now it may also give you the answer in terms of a decimal number, in which case it would be about 0.866. Similarly, cosine 42, right here, it gives me as 0.74. Tangent of 111 is negative 2.6. Now, don't worry why this is negative. We will be talking about it later on in the next week, what this negative means. Sine of 9, 0.16 after I round it. Cosine of 73, 0.29, and again tangent of 112, it's a negative value, negative 2.47. I just want you to keep in mind that when it becomes a function, the values can be negative. And what this negative means, we will be seeing that next week. Now you will notice that on the calculator, there are only 3 buttons for trig functions: sine, cosine, and tangent. There is no button for cosecant, secant, cotangent. So we need to follow a different procedure for finding those ratios. Now recall that there is a reciprocal relation between these ratios. Right? For example, cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. So whenever you're trying to find one of these 3 ratios, you can rewrite this as 1 divided by sine of the same angle, 57.16. You plug that into the calculator, 1 divided by sine 57.16, and it gives you 1.19. So it's pretty straightforward. You just have to identify the correct reciprocal. For example, this is going to be 1 divided by tangent 78.63. This is 1 divided by cosine of 13.795 degrees. Plug those in, you get 1 divided by tangent 78.63, 0.20, 1 divided by cosine of 13.795 is 1.03 after rounding. Okay, that's the end of this video. Next video, which is the last for today's or day 2's video, we're going to look at something called inverse trigonometric functions.